In this lesson we're going to ask ourselves whether an object positioned in a fluid will sink or whether it will float. Okay, to decide that we need to know the density of the object and the density of the fluid. So let's say that in this particular case our object has a density equals d object and our fluid has a density d fluid. So if the density of the object is less than the density of the fluid that surrounds it, then the object will rise to the top of the fluid and float. And so if the density of the object is greater than the density of the fluid, then the object will sink. So the most common fluid that we're going to deal with is water, and water has a density of 1 gram per cubic centimetre. Well, you can answer that typically a piece of softwood has a density of typically about 0.5 grams per cubic centimetre. So because softwood has a lower density than water, it will float on the water, whereas iron, which has a density of 7.87 grams per cubic centimetre, well, that will clearly sink because it has a greater density than water. So we can explain why some materials sink or float because of their densities. Likewise, we can also explain why certain liquids float or sink on top of others. So for example, if I have some water here and I were to add some cooking oil to the water, well, we remember again the water has a density of 1 gram per cubic centimetre. Now if I were to pour cooking oil into the water, it would initially appear to mix around, but actually the two don't mix, and after a short while they will separate. And because the oil has a lower density than water, typically about 0.9 grams per cubic centimetre, then the oil will float on the water because the density of oil is less than the density of water. So okay, a fluid is not necessarily a liquid. Fluids can also be gases. So you can imagine we're holding on to 2 balloons, and in one balloon we've got carbon dioxide gas, and in the other balloon, say, we've got helium gas, and these balloons are at the moment being held in air. Okay, and air has a density of typically about 1 gram per litre. Now that's not really important here. What's important is we know that the density of carbon dioxide is greater than the density of air. So we can write the density of CO2 is greater than the density of air, whereas the density of helium gas is less than the density of air. So as a result of that, we would expect that when we release the carbon dioxide balloon, it will sink because its density is greater than that of air. Whereas if we release the helium balloon, it will rise upwards and eventually float at some level right up in the atmosphere because its density is less than the density of air. Okay, so by knowing the density of an object with respect to the fluid in which it is positioned, whether it be a balloon in air, whether it be one liquid mixed with another, or whether it be an object positioned in a fluid such as water, by knowing the respective densities of the two, we can decide whether the object sinks or floats.